Welcome back. So in the previous video, we had just written an equation for a line. Y in this case is equal to the slope, the cell down here, times the x value here, plus the intercept, which was this cell right here. So remember, I can double click to fill in a formula, but what you'll quickly notice is that it doesn't work for all of these data sets. And that's because if we click on any one given cell, it's now taking Q38, which is a point down here, where we want it to be using the same slope each time. So there's an easy way to adjust this in Excel. Go back to your original equation for the line. And so since we want it to use the same cell each time, we can put a dollar symbol in front of the Q, which will tell it, no matter where we drag and drop the formula, do not move that frame of reference out of column Q. We can also put a money sign in front of the number 31, which says no matter where we drag or drop the formula, stay within this row. And so when both of those things are taken together, it tells you always use Q, always use 31, so we're always going to use this cell right here. It's a way of freezing the formula. And we want to do the same thing for the y-intercept. And now you can see when we double click, it runs through the operation appropriately. If I click on this cell right here, we see now that it's taking Q31, which is our slope, times our x-intercept, times our x value plus our y-intercept. And so next I'm going to calculate the residual for each data set. So remember, this is our equation for the line, or our black dotted line here, and I want to know the distance that points fall away from that line. So I'm going to write this as the fit line minus the measured line. You can see in this case that the fit line is 41 points lower than the actual calculated line. And we can do that for each position. And so in this case, you can see that all of our residuals are negative, which means that our line is significantly biased to give a lower value than the actual value. And that's okay at this point because we took a random guess at the slope and intercept to start with. That's okay. So one thing that we will get into, if you look at these residuals, in reality, some data points are going to fall above and below because they're not biased. So we want a way to set those equal to one another. And so the easiest way to do that would be to take the absolute value. And that would just give us the distance that something falls from the line, not necessarily whether it falls above or below. Computationally, the easiest way to do this is to take the root mean squared. And so what that means is we're going to take the residual, we're going to take the square of that. So the square of any negative number becomes positive. So I'm going to put that in parentheses to keep our order of operations. And then we're going to take the square root of that. And if you remember, the square root is the same thing as raising something to the 1/2 power. And so this is going to return the exact same value, but it's going to give our values as all positive numbers. And so if you look at the graph on the right, when we come up with our own trend line, remember that's what we're doing now, we're going to make our own trend line, and we're not going to rely on the one that Excel gave us. But for our trend line, we want to minimize the distance that all of those points are from the line. And so one way that we can think about that quantitatively is we can take the sum of the root mean squares. So I'm going to write equals sum, and it's all of these values. So if every single one of my points fell directly on the line, my sum of RMS would be 0, and that would be a great fit to the data. In this case, you can see that it is not a great fit. It's 1,200 and almost 70 points off. But we know that that's okay because we just guessed values here. So next what I'm going to do is I'm going to show you how you can get Excel to run a function to solve what the slope and the intercept should be such that you have a low sum of the root mean squared residuals. So the way we would do that is first you have to install a plugin. You typically do this by going to File, Options, and in this tab, click on Add-ins. And then you want to click on Solver Add-in. Don't click OK at this point, it'll just exit out. You want to click Go. And then in this new window, if it isn't already selected, select Solver Add-in and then select OK. And if you have not previously added Solver, now when you click on your Data tab, you'll see a Solver icon up here. And that's what we're going to utilize for this fit. So this new window in Solver has a few parameters that we're going to fill out. First, we have to set an objective. Our objective here is to change these values to minimize our sum of RMS. So I'm going to select this box, come over here and say this is the value that I'm interested in minimizing. I want to make that value much smaller. And remember that number right now is about 1,300. How am I going to do that? I want to do that by changing variable cells. In this case, my variables are the slope and the intercept. So I'm going to come back here and I'm going to select those two cells where I already guessed values. And now I hit solve.